everyone! Today we are going to have a look at two our instruments, KD140 and B4. Both of them are designed to measure signals from complex mutual induction of transducers like differential transformer pressure gauges. They are of almost the same size, as you can see. B4 is a bit shorter and 10 mm wider. Its mounting shouldn't cause any difficulties. We connected B4 to transducer simulator, and you can see it on the right. So now let's observe how they look like a bit. Now, let's have a closer look at B4 instrument. B4 is absolutely digital one. Its indication elements are bicolor LED semicircular bar graph with highlighted set points. Also, there are 4 LEDs of set points and a graphic display. The graphic display shows exact values of the measured parameter, relay state like R1 and R2, date, time, start and end of the range, and the units of measurement. When the signal increases and goes over the set points number 3 and number 4, indicators light up. This instrument has 2 relays, but there may be 4 of them. Then each set point will correspond to its relay. As you can see, relays are set for the second and the third set points. When they are triggered, the relays close and open. You can operate the instrument only after entering the password. All settings are protected by the password protection. There are several ways to display the information on the screen. Now you can see not only the exact values of measurements, but also the history. It's a chart which can change on a certain scale. Now it's on the 1 second per division, and you can change it to 10 seconds per division, etc. We can see the parameters change with time, if they are growing or decreasing, which is very convenient. Also, on this chart you can see set points. On the left there are set points below the norm, and on the right 2 set points over the norm. You can watch a video of horizontal bar chart. Here you could also see set points to the left below the norm, to the right over the norm. There is one more way of displaying the data, horizontal chart. Here you can more accurately see the parameter changes. Also, you can change the scale, and there are set points as well, below the norm and over the norm. And now I would like to go back to the main menu. To enter the main menu, we need to enter the password first, as that's the only way to see the setting menu. The password here is 1000, and we are entering it and going to the setting menu. Here you can adjust input and output signals, flow meter, system, operational archive, and PID controller. This time we aren't using flow meter and PID controller. Let's see input signals menu. Input signals include analog and discrete input. Let's have a look at analog input menu. In input signal, you can adjust range, curve, calibration value, and measurement scales, recording period, and mathematical process. I would like to have a closer look at range settings. It can be from 0 to 10 and from -10 to +10. Curve can be linear and non-linear. Calibration values can be factory and users. This is a measurement scales menu. Here you can adjust basic scale, additional scale, and measure scale, low and up values for each range. We will explain why you need a precise range a bit later. After it, we choose measurement units out of a standard set. You can also change and complement this set if you wish. Now I would like to go back in our menu and show you how to adjust the period of data recording to SD card, which is from 0.1 second to 99.9 seconds. Also, you can adjust mathematical processing of the signal. It's a filter which flattens out peak pulses and shifts of value, both in magnitude and angle of tilt, but it's not obligatory. There is a menu of discrete input registration, which we aren't using here. Then we adjust output signals. Set points are control points within which it is necessary to monitor or adjust the input signal. Set points can be switched off. They can be less than normal and greater than normal. For each set point, you have to set parameters. They include set point values, actuation hysteresis, turn on and turn off delays, and action on errors. The first set point we are considering is adjusted at 20% of the scale. The hysteresis is 0. We skipped some of the items now, and there is action on errors. Parameters of each set point are adjusted in the same way. For each relay, you adjust the set point at which it should close contacts. For example, relay number 1 is connected to a set point number 2. There are other settings which we aren't interested in at the moment. Let's skip flow meter as well and go to system settings. Here, you could set up a system access, either by password or give a free access. Here, you also set a password itself, then the language, date, and time. If we change them, the system reloads with a new date. Then we go back to our main menu and see what else we have there. For example, there is a service menu. So here you can set a display parameters like brightness and contrast. For each setting, you could see the results immediately. Here you see brightness, it goes higher and lower, and the same goes for contrast. You can reduce it or add more contrast. The next point is the number of digits you could see on the screen. If you want, you can disable several secondary information signs which won't be displayed on the screen. So let's skip unimportant information and discuss Modbus settings. The instrument is equipped with port RS485 for transferring data into information collection and display systems. In Modbus settings, you can set address, baud rate, parity bit, and data transfer. Let's go back in menu a bit. The next setting I want to show is operational archive. Operational archive is a part of the archive which is available for displaying on the instrument's screen. Operational archive is displayed as a chart in a chosen scale. As you could see, the scale is 10 seconds per division now. Alright, to see the archive, we have to go to View Archive. The size of archive is 64 values of its scale. In our case, the scale is 10 seconds, so the size of the archive is 640 seconds. If the scale is 1 hour per division, it will be 64 hours. We will skip PID controller, and when we deal with all the settings, the system will ask us if we want to save changes. I want to finish the overview of the instrument with the information about the permanent archive, which is stored on SD card of the instrument. If you open a slot and extract the SD card, you can copy the archive on your PC and view it there. As you can see, the instrument works even without SD, with the operational archive only. We put the SD card in an adapter and connect it to your PC. Then, alright, just a moment. Then you open USB device and install the software to open the archive. The program is installing. Then you click on Finish and open a folder with archives. Each has its name, which is its registration date. Let's open our last archive. I'd like to change the scale as our archive is short, and then let's have a look at what we can do here. So we can maximize the archive viewer to full screen, click at any place, see the precise parameter value at the moment. On the right, you also could see two lines. These are the positions of relay when the relay is on and off. Statistics is also available. You can highlight the range and see minimal and maximum value within this range. You can scale it and enlarge. You also can save this document to Excel table and print it out. Actually, that's pretty all you could do with the archive. Thanks a lot for watching, and in case you have any questions, contact us any moment. Bye bye!